Okay, class, this is examples of hypothesis tests from Chapter 8 homework. So, when you're doing these, you read the question, and you look for keywords to let you know if you're doing a z interval, a t interval, or a one prop z interval. So when I'm looking at this, I see test the claim. That lets me know that I'm doing a hypothesis test. So let me pause it on here for you to see. This is you can pause it and write this down here. It kind of cuts off the left side here, but it says, are you estimating P, a population proportion? And this one says, if yes, then you're using a one prop z interval instead of one prop z test. It says one prop z interval. So it looks basically the same as this over here, except it says one prop z interval. Okay, but in this situation, in Chapter 7 and 8, you're either going to be doing a confidence interval or a hypothesis test. So based on what we just saw, where it said test the claim, that lets me know I'm going down here. Alright, and then I start reading the next question. Okay, so let's look at the next part and see if we can come up with what the next path we're going to take. Alright, so it says we got a survey of this many out of this many, and then test the claim of a percentage. So we're testing, is it about a population proportion? Yes. So we're going to use a one prop z test. Okay, so I'm going to go to my calculator. I'm going to press on first, and then I'm going to press stat, go over to test, and I'm going to look for one prop z test. There it is, number 5. Hit enter, and then it asks what's the claimed value of the population proportion. Well, that's 15%. Make sure you write it as a proportion. Okay, you're going to want to write it as 0.15. So that means h naught is 0.15. So if you look at all of our options here, all of them that have h naught as p equals 0.15 are the ones that we can have. Okay, remember the null hypothesis has to have equality to put the center of the bell curve. So we have equality for D, we have equality for A, we have equality for C. Okay, the rest have some sort of inequality for the null hypothesis, so they're thrown out. But then it says test the claim that more than 15%. That's what we're wanting to show, or that's what the null hypothesis needs to be. Is the order symbol has to have a greater than symbol. Okay, so this is the only one, E, that has a greater than symbol here. So that's the one we'll pick to be our setup. Alright, what's the test statistic? How do you get the test statistic? You run the test. Okay, so I need this to be my null hypothesis. So I need 0.15 here in P naught. Alright, so I'm going to change that to P naught equals 0.15. Alright, that naught there in H is the same as that naught there in the calculator. So I'm going to type in 0.15. And then X comes from the information given up here. 177 said they use email, so that goes there. And then N is 980 because that's how many were surveyed. Okay, and then down here these are the equality symbols, inequality symbols, so we need to highlight P naught. Greater than P naught, and then tell it to calculate. The very first thing underneath the summary of your test is your test statistic. So that 2.68 roughly to 2 decimal places is what we'll put in there as our test statistic. Over here. Okay, so there's our test statistic. What's the p-value? The p-value is right underneath the test statistic. The p equals, that's not p hat, that's not the claim population proportion here. That's the p-value, the probability of seeing that particular statistic. So just don't confuse p hat with the p-value. Okay, those are completely different. And then it's just showing you the next thing down, 177 divided by 180. That's what the p with the little hat on it represents. So that's where that 0.1806 that's below the p-value. That's just letting you know what p hat is. All right, the probability of getting that particular value is that value or higher is 0.0036 if it really is this really is true. If there really is a 15% of households use email as our population parameter, the probability that we are this far away, or the probability that we're getting that value for our p hat, is extremely rare. We're getting down below even 1% now, not even 0.5%. So it's extremely rare. So when the p-value is less than your level of significance, then you reject the claim. Alright, so if we reject this claim, it's in support of the alternate claim. So that means that there is, at the alpha 0.01 level of significance, because the p-value is so much smaller than the level of significance, then there is evidence to support the alternate claim. Alright, is the conclusion valid today? Why or why not? No, the conclusion is not valid today because the population characteristics of email use are extremely higher than this number. I mean, 1997 versus 2013, you know that it's going to be drastically higher than 15% now. Alright, if we look at this next example, again, I see a percentage right here. So when I see a percentage and when I'm seeing things to test a claim about a percentage, that goes back to what we were talking about before. We're doing a test. Is it about a claim value of p? Yes. So it's a 1 prop z test. So if I'm looking at this, the claim is 70%, so that's going to be our p equals 0.7, just like it is in so many of these. Okay. So if we're going to test the claim that 70% of adults said it is morally wrong to not report all income tax returns, our null hypothesis is going to be p equals 0.7, but it doesn't say anything about it being one way or the other. So we're going to say as our alternate hypothesis, we're going to use choice E. So let's select E, check it, that's great. Alright, the test statistic, remember, how do we get the test statistic? We run the test. So if you look here, we got our claim is 0.7, so we're going to let that be what goes in here. So there's the P naught is 0.7. Alright, X is the number that said it is morally wrong, so 587. N is the number that says it's not. Or, I mean, sorry, the number in the poll. And then we're doing a not equals or a two-tailed test. Okay, calculate. Z, the test statistic, is the very first number we see underneath the summary of the test. Alright, rounded to 2 places. And the p-value, again, one line underneath that is your p-value. Now notice this is in scientific notation. When you see 1 point something, remember, a p-value is a probability. A p-value is a probability. A probability can't be 1.6. Okay, so if you see something bigger than 1, you need to look to the far right and notice that it's in it is in scientific notation. So when I tell it the p-value, round to 4 decimal places is needed. Well, if I write this in expanded form, I've got all these leading zeros. It keeps going after that, but I only need 4 decimal places. If you count it over, that's just a bunch of zeros. So I'm just going to put in point and then 4 zeros, decimal point 4 zeros. All right, and then identify the conclusion. So again, the p-value is, I mean, it's basically impossible for this to be equal to 70%. So we reject the claim because there is sufficient evidence to warrant a rejection of that 70% claim. Okay, the p-value method means if p is less than 0, then you will reject the null hypothesis. Okay, and then this normal distribution is an approximation of the binomial. That just means that we can use the t test, the z test, the 1 prop z test. In this case, it means the 1 prop z test when we use the normal distribution as an approximation of the binomial. This is a binomial distribution, but because of the sample size, we can use the normal distribution to approximate it. So that just means that we can run a 1 prop z test to get these 2 values. Okay, so just notice when you see that it is allowing you to do to use a 1 prop z test to do this. Alright, so check my answer, good. Alright, now in this example, notice this question says use this significance level to test the claim. So we're doing again a test about a mean. Okay, so now we're doing a test about a mean, not a proportion. Alright, so now when I look at this, are you testing the claim value of p? No. So now that question goes to, do you know the population standard deviation? Assume the population standard deviation of song lengths is this. So it is known. We do know the population standard deviation, so that's a yes. So that means we're using a z-test. Okay, so a z-test is going to be used here to conduct this hypothesis test. Alright, and then which one do we know? Alright, we know we need equality. Alright, so it's going to have to be this one. Alright, what's the test statistic? We run the test. So we go in here, this is a z-test. We have stats. Alright, what's the claims value? The claim value is 210. We get that right here. This is the right one. 210. Alright, what's the population standard deviation? That's right here in the wording. Population standard deviation is known to be 53.5. Alright, what's our sample mean? Right here, 250 hit song has a mean length of 250, so our sample mean is 250, and then our sample size was the 50 right there. Alright, and then this is a right tail test, so we're going to highlight the greater than. Okay, so there's all the data that goes in. We hit calculate. There's our test statistic, that very first number that shows up. So 0.529 to 2 decimal places. Alright, then the the critical value. So for this one, this is a right tail test, so we only have one critical value. So at a 0.05 level of significance, we use inverse norm to find our critical number. So remember, it's inverse norm because it's a right tail test. The area in the right tail is 0.05, so that means the area in the left tail is going to be 1 minus 0.05. So we subtract that from 1, or we can just plug in the number and then just take off the negative sign because it's in the right tail. So you always have that option too. You just have to remember, if you're in the right tail, you take the positive value of what pops out of there. Alright, so our test statistic is way beyond our critical number. If you want to subtract, there's that other way that you can get the positive value without having to take the negative sign away. It's just because of that symmetry of the z distribution. Alright, critical number is 1.645. Our test statistic is way beyond that, so that's when we reject. If we're further out than the value that we're considered rare, 1.645 is our cutoff for rare, then we reject. So there is sufficient evidence to support the claim, the alternate claim. Alright, very similar problem in the claim and everything. That same manual about how to have another number one song stated that your song must be no longer than 210 seconds. Okay, we took a simple random sample of 40 current hit songs, and results had a mean length of 237.4 and a standard deviation of 57.16. Right, nowhere in there does it mention a population standard deviation. What you absolutely have to have down for the difference between a z-test and a t-test is a z-test requires a population standard deviation. Alright, every data set will have a sample standard deviation. No matter what, every sample of data will have a sample standard deviation. It's in addition to that, do you also have the population standard deviation, is when we tip it in the favor of the z-test. Alright, so back to this flowchart. We're testing. Are we testing the claim value of proportion? No, it's about a mean. Do you know the population standard deviation? This time, no. We do not know it. It's a t-test. We have no idea what the population standard deviation is. Alright, we know the sample standard deviation is 57.6. So this is a t-test. Alright, so greater than 210, so that means we have to have equals 210 and greater than 210, so that's going to be our null and alternate. Alright, to get the test statistic, if they give you a mini tab display like they did here, you can click that. If not, you would just run a t-test to get that test statistic. But since they gave it to us here, I'm going to click that display, and then there is our t critical value right there, the 3.03. So I'm going to type that in. Oops, 3.03. There we go. Alright, and then the p-value, again, that's what's right beside it, right here. So the p-value is 0.002. Alright, identify the critical value. Now remember, critical value in a t-distribution is different from the critical value in a z-distribution. To get a critical value in a z-distribution, we put that 0.015 in the right tail and use inverse norm on our calculator to get us there. Okay, we're trying to determine what is that 3.03 far enough away. Now, inverse norm works for z. Inverse norm does not work for t. Okay, it is not a z distribution. It is not a normal distribution. It's a t distribution. So we go to the t table. That's where we get our critical t values. Okay, now we need to know the area in the right tail is 0.05, so that means area in one tail is 0.05. So we're in this column, the fourth column there. And then we need to know the degrees of freedom. So there's 40 in our sample, so that means our degrees of freedom is 39. So we scroll down to 39, and we're looking in the fourth column there. So the 1.685 is where it intersects with the 0.01 or 0.05 in the right tail, or in one tail. So that's the critical number, 1.685. You use your table to get your critical number. You can use your calculator for the critical number for a z test. Alright, and then again, what's our final conclusion? We're going to reject because that test statistic is so much further out than the critical value. Remember, the critical value is the minimum number of standard deviations that we can be away. So we're going to reject. So we're going to either do B or D, and just read the wording to make sure that you reject. If you reject, it's because there is sufficient evidence to support the alternate claim. Alright, so we rejected based on the fact that we can support the alternate claim.